Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on radioactivity from March 2021 paper 2. And this paper is for Cambridge AS Physics 9702. For part A, it is given to us the results of alpha particle scattering experiment provide evidence for the structure of the atom. According to result 1, or simply you can say, according to first observation, the vast majority of alpha particles pass straight through the metal foil. In many books, they only mention gold foil, so it's the same thing, are deviated by small angles. Result 2, or the second result, according to this result, or according to this observation, a very small minority of alpha particles is scattered through angles greater than 90 degrees. From these results, we need to state what may be deduced from these results, means what we can deduce from result 1 and what we can deduce from second result. First of all, let's try to understand a little bit more about these observations. If you look at this figure, in this figure you can see this is source of alpha particles, and here we have detector, and here we have gold foil, means the metal foil. Now, if you look at this second figure, means if you look at only one atom. So this is representing only one atom. And you can see at the center of the atom is nucleus. And most of alpha particles, they just went straight through this atom. And this is our first observation. And this, according to second observation, if you look at this atom, you can simply see that from here, alpha particle is deflected back, and the angle it is deflected at an angle greater than 90 degrees, because this angle with horizontal is 90, and so this angle is greater than 90 degrees. And very few alpha particles, they scattered at an angle greater than 90 degrees. And this is our second observation, our second result. Now, according to first result, what we can say about structure of the atom? Simply we can say that, as you can see, most of alpha particles, they went straight. It simply means that most of an atom is empty space. So we can say most of an atom is empty space. So this is what we can conclude from this observation. This part has only 1 mark, and that is B1. So if you have written this mark, you will get 1 mark. Let's move on to second result. Now, question is asking us what we can conclude from the second result. According to second result, a very small minority of alpha particles scattered through angles greater than 90 degrees. So what this one is telling us, if you look at this one, first thing you need to understand why alpha particle is deflected back. Alpha particle has a positive charge, so this is the charge on alpha particle. This is positively charged, and the charge on alpha particle is equal to plus 2e. If this is deflected back, it means there is an other charge is present that is repelling this one backward. So it means the nucleus is charged. So first thing we can simply say that from here, nucleus is charged. It means there is positive charge in the nucleus. So nucleus is charged. So this is one point we can write down. The second thing we need to understand is that the mass of, from here we can also conclude that mass of an atom is concentrated in the nucleus, because most of alpha particle, they went straight through. It means nothing is in this empty space. So the mass of this one is concentrated in the nucleus. So simply we can say that mass is concentrated in small region, or we can say mass is concentrated in nucleus. Simply we can write down mass is concentrated in small region, and that small region actually is nucleus. We can also write down in nucleus. So if you write on these 2 points, you will get 2 marks, because this part has 2 marks. The first mark is if you have written nucleus is charged, you will get 1 mark. And the second mark, if you have written mass is concentrated in nucleus, you will get second mark. And these 2 marks are B marks, means it has to be in your answer. For part B, it is given to us a radioactive decay sequence contains 4 nuclei P, Q, R, and S. It is also given to us nucleus S is an isotope of nucleus P. First of all, let's try to understand what is isotope. Isotopes are atoms of the same element with same number of protons. Means isotopes, they have the same atomic number, or simply we can say they have the same number of protons. So this is first thing we need to understand. Isotopes, they have the same number of protons, or they have the same atomic number. But isotopes, they have different mass number. Different mass number simply means that they have different number of neutrons because they have the same number of protons. So the number of neutrons, they are different. And they're atoms of the same element because they have the same atomic number. So number of neutrons are different. So this is one thing we need to understand what is isotope. Now it is given to us nucleus S is an isotope of nucleus P. It means nucleus P and S, they have the same atomic number. So the atomic number of nucleus S is also 84. So this is atomic number of nucleus S. Now let's try to understand what is happening from P to Q. So when P decays to Q, you can see atomic number decreases by 2. So we can simply write down atomic number decreases by 2. And if we go from P to Q, the mass number decreases by 4. So it simply means this one is alpha decay. So we can write down this is alpha decay. Now if we look at the second one now, Q to R. So what is happening from Q to R? If you look at this one, atomic number increases by 1. But if you look at the mass number does not change. So simply we can say there is no change in mass number, but atomic number decreases by 1. So it is simply beta minus decay. So this one is beta minus decay. Now we need to understand what is happening from R to S. If we go from R to S, atomic number increases by 1. So we can simply say atomic number increases by 1. If atomic number increase by 1, so it simply means this is also beta minus decay. So this is beta minus decay because atomic number increases by 1. So in beta minus decay, mass number does not change. So it means the mass number will not change. So these are the basic things we need to understand what is happening. Now, if the mass number does not change, so the mass number of S is the same as mass number of R. So simply we can write down here the mass number for S. This is 214. Question is asking us the number of protons. Determine the proton number and the nucleon number of nucleus S. Nucleon number is the same as mass number. Now simply we can write down from here proton number of S is 84 and the mass number of S is 214. This question has 2 marks. If you write down 84, you will get 1 mark. And this is the answer mark. So simply you need to write down 84 to get this mark. And the second mark is also answer mark. If you simply write down 214, you will get second mark. For second part, it is given to us the quark composition of a nucleon in Q changes as Q decays to form R. We need to describe this change to the quark composition of the nucleon. First of all, let's try to understand what is nucleon. Maybe some of you are not clear what is nucleon. Nucleon simply is a particle in the nucleus. So simply we can say nucleon is a particle in the nucleus. So simply we can write down particle present in the nucleus. And examples of nucleons are protons because protons are present in the nucleus. And neutrons are also examples of nucleons. Now, if you look at this given nuclear decay means radioactive decay, we can see when Q decays to R, there is no change in the mass number. But if you look at atomic number is increasing by 1. If atomic number increases by 1, it means proton number increases. But the mass number is not changing. It means neutron number decreases. So simply from here we can write down, in this case, one neutron becomes proton because number of neutrons decreases by 1 and number of protons increases by 1. So this is the first thing we need to understand. Now question is asking us, we need to describe this change to the quark composition of the nucleon. So in this case, nucleon, neutron changes to proton. We need to describe the change to the quark composition. Now, if you look at quark composition of neutron, it consists of one up quark and two down quark, and proton consists of two up quarks and one down quark. So from here simply we can say that one down quark changes to one up quark, and that's all what you need to write down. If simply you write down one down quark changes to one up quark, you will get 1 mark, and this is B mark, mean it has to be in your answer. So simply if you write down this much, you will get 1 mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on standard model from May June 2021 paper 2-1. I said this is typical type of question because this type of questions are very common in past papers, and these type of questions have been asked many times in the past. For part A, it is given to us a proton in a nucleus decays to form a neutron and a beta plus particle. Beta plus particle in fact is positron. So this is antiparticle of electron, and this positron is a lepton. So we need to understand positron is a lepton. So this belongs to lepton family. For part 1, we need to state the name of an other lepton that is produced in the decay. In this case, beta plus particle is emitted. So this tells us this is beta plus decay. So let's try to understand, first of all, what is beta plus decay. If beta plus particle is emitted, it means this is beta plus decay. If electron is emitted, it means this is beta minus decay. So this is beta plus decay. Let's say we have one nucleus X. Atomic number of this one is Z, and this nucleus decays to an other nucleus by beta plus decay. So by beta plus decay. So this is our beta plus particle. So you can also write down it has charge plus 1 and it has mass number 0. So in this case, we can simply write down the Z. This will be Z minus 1 because this is plus 1, and this has to be A. Mass number will not change, and other particle is emitted. So beta plus particle, this is antiparticle. So in this case, electron neutrino will be emitted. So electron neutrino has no mass number and also no atomic number. So simply we can write on here. So this is electron neutrino. So the way to remember this one is, look at this particle. So if this is antiparticle, we can simply write down, if this is antiparticle, means if this is positron, that is antiparticle of electron. This one has to be particle, means this has to be neutrino. So this one has to be particle, and vice versa is also true. If this is particle, means if this is electron, this one has to be antiparticle, means electron anti-neutrino. So this is the point you need to understand, particle and antiparticle. This is due to lepton number, means the lepton number has to be conserved. That's the reason one has to be particle, other one has to be antiparticle. Because lepton has a lepton number plus 1 and anti-lepton has a lepton number of minus 1. So that's the reason one has to be particle, other one has to be antiparticle to conserve lepton number. So for the answer of this question, simply you need to write down electron neutrino. So we can write down electron neutrino. And this question has 1 mark, and that is B mark. So it has to be in your answer. If you only write down neutrino, still you will get 1 mark. But the proper way of writing is electron neutrino, because there are different types of neutrinos: electron neutrino, muon neutrinos, and tau neutrinos. So this is electron neutrino, so the proper way of writing is electron neutrino. But in order to get marks, if you only write down neutrino, still you will get 1 mark. For the second part, we need to state the name of interaction that gives rise to this decay. This is typical type of question, and for this one we need to understand when quark change from one flavor to another flavor, or simply we can say when quark change from one type to another type, or simply we can say when the down quark it change into up quark, or vice versa is also true. If up quark change into down quark or any other type of quark, when it change from one form to another form, the interaction, the force responsible for that is weak nuclear force. So simply answer for this question, you need to write down weak nuclear force. And weak nuclear force is also responsible for fusion process in the sun. So weak nuclear force, when quark change from one form to another form, force responsible is weak nuclear force. Nuclear fusion process is taking place in sun, so the force responsible for that nuclear fusion is also weak nuclear force. Because when protons they combine together, they form helium nucleus, and in helium we also have neutron. So protons change into neutrons. So the quark is again means change from one form into another form. So weak nuclear force is also responsible for that. So this is what we need to understand. This question has only 1 mark, and that is B mark. So it has to be in the answer. This is what you need to write down. You can write down weak nuclear force, you can write down weak nuclear interaction. And this force, weak nuclear force, it has the shortest range, and the range of this force is about 10 to negative 18 meters. Even this range is shorter than strong nuclear force. Let's move on to next part. For the next part, question is asking us state which of the three particles, proton, neutron, and beta plus particle, has the largest ratio of charge to mass. Simply is asking us Q by M. Which one has greatest ratio of Q by M? First of all, let's look at proton. For proton, the charge on proton 1.6 times 10 to negative 19 coulombs, and the mass of one proton is about 1.66 times 10 to negative 27 kg. So this is Q over M for proton. So we can say this is for proton. And for neutron, so we can write down here Q over M for neutron. Neutron has no charge, so this is 0. And the mass of neutron is about 1.67 times 10 to negative 27 kgs. We can also do the same for beta plus particle. For beta plus particle, the charge on beta plus particle is the same as the charge on single electron, or we can say as the charge on single proton. So this is 1.6 times 10 to negative 19 coulombs. So we can write on here. And the mass of beta plus particle, it is the same mass as mass of single electron, and the mass of single electron is 9.11 times 10 to negative 31 kgs. Now simply we need to compare them. So QM for neutron, this will be equal to 0 because there is no charge. But now we need to compare proton with beta plus. So you can see they have the same charge, but the mass of proton is greater than the mass of beta plus. So it means this number is small, but this is the same for proton, same for beta plus. So it means Q over M for beta plus is higher than Q over M for proton. So simply we can write down our answer is beta plus particle. So it has higher Q over M ratio. So the answer is beta plus particle. And this question has B1 mark, means that only one B mark, and this has to be in your answer. For the next part, we need to use the quark model to show that the charge on the proton is plus E, where E is the elementary charge. First of all, let's try to understand what is quark composition of proton. Proton consists of two up quarks and one down quark. The charge on one up quark is plus 2 by 3e, and the charge on one down quark, this is minus 1 over 3e. Now simply we need to add these charges together. So the charge on one up quark, this is 2 by 3e. We have two up quarks, so we can write down this 2 times, and we need to add the charge on down quark, and the charge on down quark is minus 1 over 3e. Now simply we can add these two. So plus 2 by 3e plus 2 by 3e. So simply we can say this is plus 4 by 3e minus we have 1 over 3e. Now simply we need to add, we can take LCM. So this will be 4 minus 1 times e. So if we simplify this one, our final answer will be plus e. So the charge on single proton is equal to plus E. This question has 2 marks, and the first is if we have written the quark composition for proton, we will get 1 mark, and this is B mark. I mean, it has to be in your answer. And the last one is, this is also B mark. If we have shown that our final answer means the charge on the proton is plus E, you will get the second mark. For part 5, we need to describe the change to the quark composition. But for this question, it is given to us proton changes to neutron. So simply we can write down, first of all, proton changes to neutron. So we can simply write down here, proton changes to neutron. Now we need to write down the change in quark composition. Proton consists of 2 up quarks, 1 down quark. But neutron, it consists of 1 up quark and 2 down quark. So this is the change, means 2 up quark and down quark changes into 1 up quark and 2 down quark. Or simply we can say, in this case, 1 up quark changes into 1 down quark. So that's all what you need to write down for this question. And this question has 1 mark. If you have written this one, you will get 1 mark. Means if you have written up down quark changes to up down quark, you will get this 1 mark. For part B, it is given to us a nucleus X, the proton number is 6, our atomic number is 6, and mass number is 12, and the nucleus Y, mass number is 16, and proton number is 8, or we can simply say atomic number is 8, are accelerated by the same uniform electric field. We need to determine the ratio between the electric force acting on nucleus X and electric force acting on nucleus Y. First of all, let's try to understand what this is telling us. If you look at nucleus X, so it has atomic number 6 and the mass number is 12. So the charge on this one means the charge on X, this is equal to its atomic number. So simply we can say this is 6e plus, means 6 times the charge on single proton. Now if we look at nucleus Y, for nucleus Y, proton number is 8, meaning atomic number is 8, and the mass number is 16. So the charge on this particle is equal to 8 times the charge on single proton. These two, they are accelerated through the same electric field, and the field is uniform. Same uniform electric field. So we can place these two nuclei in this electric field. So we can assume we have nucleus X here, so it has atomic number 6, its mass number is 12. And we have another nucleus Y, its atomic number is 8, its mass number is 16. They are accelerated in this uniform electric field. So as it is uniform electric field, it means E is same everywhere in this field. We can simply say E is same. Now we need to find the ratio, so we can write down the ratio. This is the force on X divided by the force on Y. Where the electric force is equal to E times Q, so we can say this is EQX and this will be EQ y. E is the same, so we can simply cancel E with E. So we left with qx. And the qx, we can write down, this is 6e plus 8e plus. Now if we simplify, so e plus we can cancel. So our final answer will be 0.75. And this is the final answer what we need to find out. This question has 2 marks. The first mark is if we have used this equation, so you will get C1 mark. And the second mark is the answer mark. If you have got the right answer, you will get 2 marks for this question. For part 2, we need to determine the ratio between acceleration of nucleus X and acceleration of nucleus Y. So they're still in the same uniform electric field. So this is given to us. They are in the same uniform electric field. So let me redraw. So this is uniform electric field. This plate is negative plate, so this is negative plate, and one plate is positive. So the electric field between these 2 plates is uniform electric field, means value of E is same everywhere. So they are accelerated in this uniform electric field. So we can say this is nucleus X and this is nucleus Y. Now we need to find the ratio between their acceleration. So simply we can start from here. So the ratio you need to find between AX by AY, and acceleration is equal to force divided by mass. So this will be the force on X divided by mass of X. And we need to divide this one by acceleration of Y. So this will be the force on Y divided by the mass of Y. Now we can simplify this and we can write down this will be force on X times the mass of Y nucleus divided by, this will be the force on Y nucleus times the mass of nucleus X. We can further simplify. We can see that electric force is equal to EQ. So we can replace with F with E times QX. And here we have mass of Y. And same we can do for Y, Fy. F is equal to E times the charge on Y times the mass of X. Now from here we can simply cancel E because E is the same. They are in the same uniform electric field, so we can cancel this. So we left with this is QX divided by QY, the ratio between these 2, and times the ratio between mass of Y and mass of X. Now we have already found the ratio between QX and QY, that was equal to 0.75. So simply we can write down 0.75. Now we need to find out the mass of Y and the mass of X. Mass of Y, this is equal to 16U. The mass of Y, this is equal to 16U. But 1U is equal to 1.66 times 10 to negative 27 kgs. You don't need to write down in form of kgs, but if you want to write down, you can do that part as well. And the mass of X is 12U. So simply we can plug in these values here. So the mass of Y is 16U and the mass of X is 12U. So simply U we can cancel, or you can plug in values in terms of kgs. You can write down, you can say this is 0.75. This is multiplied 16 times 1.6. If you're a little confused with U, so you can just write down in terms of kgs. And this is divided by 12 times 1.6 times 10 to negative 27 kgs. Now we can cancel out. So 1.6 times 10 to 27 we can cancel. So we left with 0.75. This is multiplied with 16 divided by 12. So if we solve this one, our final answer is going to be 1.0. And this is the ratio between acceleration of X and acceleration of Y. This question has only 1 mark. If you got the right answer, you will get that mark. I have explained in detail, but because sometimes some students they are confused with little points, so I have explained you in detail so you have clear picture of this question. For this question, it is given to us nucleus X is at rest in the uniform electric field at time t is equal to 0. The field causes nucleus X to accelerate. On figure 6.1, we need to sketch the variation with time t of the acceleration A of nucleus X due to the field. First of all, let's try to understand uniform electric field. In uniform electric field, so let's say this plate is positive. We can simply imagine this plate is positive and this plate is negative. And the electric field between these two plates will be uniform electric field. As we have discussed before, E is the same everywhere in this field. So that's the reason we call this is uniform electric field. Now for this question, it is given to us a nucleus X is placed inside this one. Then this nucleus X has positive charge, so it will accelerate in this direction. Now we need to find out how A will change with time. If we look at this nucleus X and if we need to calculate its acceleration, so that will be simply equal to the resultant force on nucleus X divided by the mass of nucleus X. So the net force acting on this particle is only electric force. So we have written EQ over M. Now if we look at E is the same because electric field is uniform. Q is the same because the charge on particle is not changing. M is the same, so M is not changing. So it simply means that X has uniform acceleration. Acceleration is constant. It will not change with time. So simply we can draw the horizontal line, mean the acceleration of particle X is constant. So that's all what you need to do. If you draw this horizontal line, you will get 1 mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on radioactivity and standard model for March 2022, paper 2, variant 2. In this lesson, we will discuss what are leptons and what kind of leptons are produced in any beta plus decay. Then we will talk about nuclear number and proton number. We will also discuss what are baryons, what is the quark composition of baryons, and how we can determine the charge on baryons. For part A, it is given to us a nucleus of sodium-22 decays by emitting a beta plus particle. A different nucleus is formed by the decay. We need to state the name of an other lepton that is produced by the decay. Question is asking us to state the name of an other lepton. If you look at this beta plus particle is positron, and positron is antiparticle of electron and it belongs to lepton family. So this is the first lepton that is already given to us. And question is asking us to state the name of an other lepton that is produced by beta plus decay. And let's try to understand first of all beta plus decay. So here we have sodium nucleus. Its atomic number is 11 and mass number is 22. And this sodium nucleus, it decays by beta plus. So simply we can say another nucleus is formed. Let's say that nucleus is Y and beta plus particle is emitted. So here we have beta plus particle, and here it has to be electron neutrino. Why this one has to be electron neutrino? Because this particle is positron and positron is antiparticle of electron. So this is antiparticle of electron. It has lepton number -1, -1. But this nucleus, it has 0 lepton number. So in order to conserve lepton number, this has to be electron neutrino. So simply the reason is that if this one is beta plus particle, this has to be electron neutrino to conserve lepton number. And vice versa is also true. If this is particle, means if this is electron, this one has to be electron anti-neutrino. You have to be very clear about this point because they will ask you this in many ways. So we can say this is positron and positron is antiparticle of electron. So this is antiparticle of electron. antiparticle of electron, and this is electron neutrino. So this is electron neutrino. There are different types of neutrinos: electron neutrinos, muon neutrinos, and tau neutrinos. That at AS level only you need to understand electron neutrino. So in answer, you can write down electron neutrino, but still you will get mark if you only write down neutrino. Still you will get marks. So better to write down is electron neutrino, but if you only write down neutrino, still you will get the mark. So this is the mark. Next question is asking us to determine the nucleon number and proton number of the nucleus that is formed by the decay. This is beta plus decay. So the proton number will decrease by 1. So here atomic number means the proton number has to be 10. 10 plus 1, 11. It has to be same on both sides. Means proton number has to be conserved. And mass number will not change. So this will be 22. Mass number is nuclear number. So we can write down here 22 and this one is 10. And also we need to understand is, if you look at this beta plus decay, very important point. If you look at these two particles, they belong to lepton family. So you have to be clear about this one. These two particles, they belong to lepton family, and they do not feel the strong nuclear force. Lepton, when we talk about leptons, it means we are talking about lighter particles. So these are lighter particles and they do not interact with strong nuclear force, or simply we can say they do not feel strong nuclear force. They do not feel strong nuclear force, or they do not interact with strong nuclear force because leptons are not present in the nucleus. And this question has 2 marks, so these are answer marks. If you have written 22, you will get 1 mark, and the second mark you will get if you have written 10, means the proton number. For this question, it is given to us the quark composition of a nucleon in the sodium-22 nucleus is changed during the decay. We need to describe the change to the quark composition of the nucleon. So first of all, let's try to understand what is nucleon. Nucleon simply means that any particle in the nucleus. So simply we can say nucleon means any particle in the nucleus is named as nucleon. Any particle in the nucleus is called nucleon. So simply we can say any particle in the nucleus. In the nucleus we have protons and we have neutrons. So protons and neutrons, we call them nucleons. Let's try to understand a little bit more about beta plus decay to answer this question. First we will start from sodium. Sodium 22 means the mass number of sodium is 22 and atomic number of sodium is 11. This decays to a daughter nucleus by beta plus decay, or simply we can say by emitting beta plus particle and electron neutrino. This daughter nucleus, it has atomic number 10 and its mass number is 22. Now we need to understand mass number. First of all, we will look at this mass number. So here is also the mass number. If you look at this mass number, sodium has 22, the mass number of sodium is 22, and the mass number is the sum of proton and sum of neutron. And daughter nucleus, this also has the same mass number 22, and this is also sum of protons and neutrons. Sum of protons and neutrons. Atomic number is 11. It means we have 11 protons here. Neutron number is 22. So 22 minus 11, it means we have 11 neutrons as well. 22 minus 11 is neutron number. But if you look at this daughter nucleus has atomic number 10. It means it has only 10 protons. So neutron number in this case is 12. So if we look at neutron number, we can see neutron number is increasing. So if the neutron number is increasing, and if you look at the proton number, this one is decreasing. So we have minus 1 here. Proton number is decreasing. The neutron number is increasing. So it simply means that in this case, one proton changes into neutron. So we can simply write down, in this case, one proton decays into neutron. So this is one thing you can write down. Proton decays to neutron. And the quark composition of proton, it has 2 up quarks and 1 down quark. And neutron has 1 up quark and it has 2 down quark. Describe the change to the quark composition. So simply we can say in this case one up quark decays to down quark. So simply we can write down in this case up quark changes to down quark. We can say up quark changes to down quark, and that is the change in quark composition. Up quark changes to down quark, and this question has only 1 mark, so this is the 1 mark. Kind of typical question you need to understand. I have explained this one in detail, but if you are very clear about this one, so beta plus simply means that proton decays to neutron. If it is beta minus, then neutron decays into proton. For part B, it is given to us a baryon consists of quarks that are the same flavor, same type. Means all of them, they are same type of quark. Means all of them, they can be down quarks, they can be anti-down quark, they can be up quarks, they can be anti-up quark, and so on. It is also given to us the charge of the baryon, that is negative 2e. This is the charge on single electron. For part 1, we need to calculate in terms of E the charge of each quark. The first thing we need to understand is that we need to understand what is baryon. So very important one. If you don't understand what is baryon, maybe it will be quite difficult to answer this problem. First of all, let's try to understand what are baryons. Fermions, I will start from fermions. Or simply you can say matter and antimatter. So fermions consist of matter and antimatter. Fermions can be classified into 2 classes. We classify them into hadrons and lepton. They can be classified into hadron and leptons. Hadrons can be classified into baryons and mesons. Baryons and mesons. Baryons consist of 3 quarks. They can be quark or they can be antiquarks. Consist of 3 quarks. Mesons, they consist of quark and antiquark. Means one of them will be quark and other one will be antiquark. So mesons, they consist of 2 quarks. One quark, one is antiquark. So meson consists of 2 quark and antiquark. So we can simply write down they consist of quark and antiquark. But baryons, they consist of 3 quarks. Hadrons, they feel the strong nuclear force. So we can say feel strong nuclear force. I'm using SN for strong nuclear force. Leptons do not feel strong nuclear force. Do not feel SN means strong nuclear force. Hadrons are heavier particles, so we can say they are heavy particles. Leptons, they are lighter particles, so we can simply say lighter particles. Examples of leptons are electrons and neutrinos. So simply we can write down here electrons and neutrinos. So these are examples of leptons. If you look at examples of baryons, baryons consist of 3 quarks. So the examples of baryons are protons and neutrons. So simply we can say neutrons. Let's try to answer part 1. For part 1, we need to calculate in terms of E the charge of each quark. But now we understand each baryon, it consists of 3 quarks. So simply we can say in this case Q is the charge on single quark. So the total charge 3Q, this has to be equal to negative 2E. From here we can find out Q, this one will be equal to negative 2 by 3E. So this is the charge on single quark of baryon, because it is given to us baryon consists of quarks that are the same type, means all of them, they have the same charge. So this is the charge on each quark of baryon if the total charge on baryon is equal to negative 2e. So this is our answer for this question. And this question has 1 mark and this is answer mark. If you have got this right answer, you will get this mark. For the second part, we need to state a possible flavor or possible type of the quarks. But we have already determined the charge on each quark. So this is the charge on each quark. Now we need to find out type of quark. For this one, we need to understand different types of quarks. So we will start from up quark. So we have first one is up quark. We use small letter U, the symbol for up quark. And in the first generation, we also have down quark. And symbol for down quark is small multi. The second generation means after up and down quark, we discover charm quark. This is charm quark. Charm quark and strange quark, they belong to second generation, so strange quark. After charm and strange quark, we discover top quark. Symbol for this one is small t. Top and bottom, they belong to third generation. Mean first we discover up and down quark, they belong to first generation. Then we discover charm and strange quark, they belong to second generation. Top and bottom were discovered at the end, so they belong to third generation. Top and bottom. Symbol for bottom quark is B. Now, if you look at the charge of these quarks, charge on these quarks. So this is first, second generation, and this one is third generation. Now we need to look at the charge on these quarks. If you look at charge on up quark, charm quark, and top quark, you can see something higher, up, charming, top, something better or something higher. So all of them, they have charge plus 2 by 3e. So this is the charge on all these quarks. They have the same charge. Now, if you look at this bottom row, all the quarks in this bottom row, they also have the same charge. And the charge is equal to negative 1 over 3e. Means the charge on down quark, charge on strange quark, and charge on bottom quark is equal to negative 1 over 3e. There is a way to remember the charge on these quarks. If you look at this top row, all the quarks in this top row, the name sounds something higher, like up, like charming, top. They sound something higher. So that's the reason the magnitude of charge on these quarks is higher and positive. Higher and positive. So I will say higher and positive. If you look at this bottom row, down, something down, strange, doesn't sound good. Bottom also lower. So all these quarks, they have lower magnitude of charge and charge is negative. So this is one way you can remember. Now let's try to answer this question now. We need to state possible type of quarks. If you look at top quark, has charge plus 2 by 3e. Anti-up quark, charge negative 2 by 3e. Now if we talk about anti-charm quark, charge on anti-charm quark will be negative 2 by 3e. And the charge on anti-top quark, that also will be equal to negative 2 by 3e. Now for this question, you can say anti-up quark, anti-up, you can also say anti-charm quark, you can also say anti, I will be writing here, you can say anti-top quark. So you can mention any one of them, you will get 1 mark, and that mark is B mark. So you will get B mark for this one. Welcome to A-Level and AP Physics. In today's class, we will discuss important past paper questions on radioactivity and electric field from October-November 2020 paper 2. These questions are very important because you will see same type of questions in many years past papers. Our first question is from October-November 2020 paper 2. 1. And for part A, we need to state a similarity and a difference between a down quark and a down anti-quark. If you simply remember the charge on down quark, the charge on down quark is equal to minus 1/3 of the charge on single electron. So simply you can write down. Now the next thing you also need to understand, what is the charge on down antiquark? So down antiquark means this is antimatter, so the charge on this one has to be opposite, that equal in magnitude. So the charge on down antiquark will be 1/3 of the charge on single electron, that this is positive. Based on this one, we can write down our answer. So simply for similarity, you can say equal magnitude of charge. So simply we can write down what is similar between these two. Equal magnitude of charge, we can simply write down like this. So they have equal magnitude of charge and opposite sign of charge, we can write down, but opposite charge. So you can say opposite charge, or sign of charge you can say, or simply if you say opposite charge. So if you write these 2 points, you will get 2 marks for this question. Let's try to understand a little bit more about down quark and down anti-quark. First of all, we need to understand down quark is a particle, or we can say it's a matter. So this is matter, or you can say particle, and down anti-quark, this is antimatter. So this is also the difference. You can also say one is matter and other one is antimatter, and both of them, they are fundamental particle. Means the down quark, this is fundamental particle, means it cannot be broken into smaller particles. So we can say this is fundamental particle. So the down quark is fundamental particle. Any type of quark is a fundamental particle. Means down anti-quark, this is also fundamental particle. Means this one cannot be divided into smaller particles. So this is also fundamental particle. So this is the similarity between these two, and this is the difference. The second thing we need to understand, matter and antimatter, or particle and antiparticle, they have always same mass. So it means down quark and down anti-quark, they also have the same mass. So they have the same mass. So this is the similarity. You can write down similarity here. So this is also similarity between these two, and this one you can use as a difference between them. You can say one is matter and the other one is antimatter. Next question is simply asking us about the number of protons and number of neutrons. If we look at this nucleus of aluminium, if we look at this nucleus, so at the bottom we have Z, means this is atomic number. In fact, this is equal to number of protons. So simply we can write down this is equal to number of protons. And 25, you can see here, 25 is the mass number. So A is mass number. We can simply write down here A is the mass number. Now number of protons, quite straightforward one. So simply number of protons is equal to 13 is equal to atomic number. We can write down here. Now the question is that how to find number of neutrons. Let's say n is the number of neutrons. So number of neutrons simply is equal to mass number minus atomic number, or you can say minus number of protons. So in this case, mass number is 25 and atomic number is 13. So the number of neutrons are equal to 12. So simply for this one we can write down number of neutrons equal to 12. Second part is asking us to show that the charge is 2.1 times 10 to negative 18 coulombs, and this is for a nucleus. For a nucleus, we need to understand in the nucleus there are protons, and also in the nucleus there are neutrons. If we look at the charge of proton, means let me write down here, charge on proton is equal to 1.60 times 10 to negative 19 coulombs. But if you look at the charge on neutron, neutron has no charge. So neutron 0 coulombs, mean it has no charge. We need to find the charge on the nucleus. So for that purpose, simply we need to understand the total charge Q. This will be equal to number of protons. In this case, we have 13 protons multiplied by the charge on single proton. So if we just multiply this, we will get our final answer, that is equal to 2.1 times 10 to negative 18 coulombs. So this is the answer. For part C, it is given to us that nucleus in part B is moved along a straight line from point A to point B. Means it is moved from point A to point B along this straight line in a uniform horizontal electric field in a vacuum. Vacuum simply means that we no need to consider air resistance. Now if you look at the force acting on this nucleus at this point, and this nucleus is positively charged, so direction of force is in in direction of electric field, so the electric force will be acting in this direction. Let's say when the nucleus is at this point, if we find direction of electric force on nucleus, again this will be equal to Fe, and its direction is to the left because this is in a uniform electric field, so magnitude of force is the same. If we consider direction of electric force on this nucleus at this point, so again this is to the left and its magnitude is the same. So it simply means that force in this case is constant and it is always directed to the left. Now if we need to find out the work done by electric force, means work done by electric force, so that will be simply equal to electric force times the distance moved in direction of force. In this case, electric force, simply we can find out this will be equal to EQ times D. EQ times D. And D is a very important thing we need to understand. So which distance we have to consider, because the force is always acting along horizontal, so we need to take the horizontal distance, means we need to take this distance. So it means D in this case, this is equal to 4.0 centimeters, or we can say this is 0.04 meters. Value of E is already given, so we can write down this is E. 11 times 10 to 3 volts per meter, so this is value of E. And the value of Q we have already calculated in part B, so that was equal to 2.1 times 10 to negative 18 coulombs. And the distance is 0.04 meters. If we all multiply, our final answer will be 9.2 times 10 to negative 16 joules. But this work done is negative. Why this work done is negative? And the distance covered, this is to the right. So the angle between them, this is equal to 180 degrees. So simply we can say work done by electric force, this is negative. But the work done by applied force, work done by applied force will be equal in magnitude, but work done will be positive. So this is the work done. Why these two works are equal? Because in this case there is no change in kinetic energy. So the work done by electric force, this is negative, and work done by applied force, means I can simply say by F force, this is positive, and that is equal to change in kinetic energy. Because there is no change in kinetic energy, it means these two work are equal. So our final answer will be 9.2 times 10 to negative 16 joules. This question is from October-November 2020 paper 2-2 and very similar to paper 2-1 from October-November 2020, because this is also asking you a similarity and a difference between up quark and up anti-quark. We have discussed a lot about this one. We have discussed quark and up anti-quark. They are matter and antimatter. So simply again we can write down the difference between these two is one is matter, the other one is antimatter. And what is similar between these two? These are fundamental particles. We can simply write down their fundamental particle, means quark is fundamental particle and anti-quark is also fundamental particle. So we can write down here anti-quark is also fundamental particle. The next thing what we can say is about the charge. The charge on up quark, this is equal to plus 2/3 of the charge on electron, but the charge on up anti-quark, because this is antimatter, so the charge has to be opposite. So this is minus 2/3 of the charge on electron. So if you have this understanding, we can write down our answer. This is how you can write down the answer. Simply you can say matter antimatter, so this can be the difference. We can say one is matter, the other one is antimatter. If we need to write down what is similar, simply you can write down both of them. They are fundamental particles. From here we can also say that magnitude of charge is the same. Up and up antiquark, they have same magnitude of charge, so they have same magnitude of charge but opposite. But sign of charge is opposite, so but opposite charge. So these things, basic things, very common question. If you are clear about this now, in future you can answer. So this is how we can answer this question. I hope it is clear. Let's move on to next. For part B, it is given to us that electron is in an electric field and electric field is in vacuum. Question is asking us on figure 7.1, we need to draw arrow to show direction of the electric force acting on the stationary electron. Means electron is at rest at this point. We need to draw direction of electric force on this. Let's try to understand a little bit about electric field. Let's say our electric field is uniform. Electric field is like this. Let's say upper plate is positive and the bottom plate is negative. So direction of electric field is down. Now if we place positive charge inside this one, let's say we place positive charge here, direction of force will be in direction of electric field. But if we place negative charge like electron inside this electric field, direction of electric force on electron, it will be in direction opposite to the field. So if you look at this one, this is our electron and direction of electric field is to the left. So the force on electron will be to the right. So simply we need to draw this arrow. So this is how we can answer part 1. If we look at second part, it is given to us the electric field causes the electron to move from its initial position. Describe and explain the acceleration of the electron due to the field as the electron moves through the field. Now when the electron is moving this way, we need to understand how electric field is changing. So the first thing we need to understand is that electric field lines are getting closer. So we can write down electric field lines. Electric field lines are getting closer, so we can write down electric field lines are getting closer. So what this is telling us, getting closer means that E increases, means field is getting stronger, so the E is increasing. So we can say E is increasing. So if E is increasing, how about the force? Force F is equal to EQ. Q is the charge on electron. If E increases, it means the force will increase. If the force on electron is increasing, so this is the force, we understand F is equal to MA. So A from here, simply we can say this is F over M. So if the force is increasing on electron, mass of electron is not changing, so it means that A will increase. So simply we need to explain that the force on electron is increasing because electric field is getting stronger, so the acceleration of electron will increase. Because the uniform, this is not uniform electric field, this is non-uniform electric field. So let me explain to you how you can write down your answer. So simply you can say the first point. This question has 2 marks. We can say electric field. So we can say the first point we can write down. So this is how you can write down your answer. You can say electric field means E increases. So this is one point you can write. Electric field increases. The second point you can say the force increases, or you can say electric field increases, so force increases, therefore acceleration increases. Therefore the third, acceleration increases. Acceleration increases. So this is how you can answer this question. For this part, it is given to us that a stationary alpha particle is now placed in the same electric field at the same initial position that was occupied by the electron before. Question is asking us, we need to compare the initial electric force acting on the alpha particle with the initial electric force acting on the electron, means that acted on the electron. In order to compare this one, first thing we need to understand what is given. It is given to us that same electric field. It simply tells us that E is the same. Electric field is the same. So this is the first thing. The second thing we need to understand is the charge on alpha particle and the charge on electron. The charge on alpha particle, the Q, this is equal to plus 2E. But if you look at the charge on electron simply is equal to minus E. So it means the charge on alpha particle, this is double than the charge on electron. That these two charges are in opposite direction. So let's try to write down the force. Now if you write down the force here, force is equal to F is equal to EQ. E is the same. So here we can write down this is plus 2E. So this is the force on alpha particle. If we write down the electric force acting on electron, that will be equal to E times minus small e. So it simply means that the force on alpha particle is 2 times as compared with the force on electron. But direction of force on alpha particle is in opposite direction as compared with force on electron. We can also draw here, for example, when our electron was here, the force on electron was to the right. Now if we place our alpha particle at this point, force will be to the left. So the force is in opposite direction. Let's say if this force is F, the force on alpha particle, this will be 2F. So that's all what we need to answer this question. If we have this understanding, then we can write down our answer like this. So there are 2 points we need to understand. You need to mention the force on alpha particle is twice the magnitude of force on electron. The second thing you need to mention is the force on alpha particle is in opposite direction to force on electron. For this question, it is given to us that there is a uniform electric field between plate X and plate Y. So these are two plates, plate X and plate Y. It is also given to us that plate X is at potential plus V and plate Y is grounded. So it simply means that here potential is equal to 0. It is also given to us that the distance between two plates, this is equal to D. Part A is asking us, we need to state expression in terms of sum or all of D, Q and V for the magnitude of electric field. Electric field simply means the capital E. This is equal to the potential difference between 2 points, or we can say in this case between two plates, divided by the distance between 2 points, or in this case we are talking about plates, so the distance between two plates. In this case the potential difference simply is equal to V minus 0 divided by the distance between them is D, so it's simply equal to V divided by D. So this is how we can answer part 1. For the second part, question is asking us the magnitude of the electric force on the nucleus, means the magnitude of the force acting on this nucleus. Magnitude of force in this case will be constant because this nucleus is in uniform electric field. So the force we can write down, in this case force will be equal to F is equal to EQ, and Q is the charge on the nucleus. It is also given charge on nucleus is plus Q. E we have already, so we can replace E with V divided by D, and this is multiplied by the charge on nucleus. So this is our answer for second part. For this part, we need to calculate the kinetic energy of the nucleus when it reaches plate Y. When this nucleus was at this point, means at plate X, its kinetic energy is equal to 0 because it was stationary. So we can say initial kinetic energy of nucleus, this is equal to 0. When it reaches at this plate, means at plate Y, it has certain amount of kinetic energy. We can say that is kinetic energy final. If we need to calculate the change in kinetic energy, that change in kinetic energy will be equal to Ke final minus Ke initial. So simply we can write down. But Ke initial, this is equal to 0. It simply means that the change in kinetic energy, in this case, this is equal to kinetic energy final. Now we need to understand the change in kinetic energy. In this case, this is equal to work done by electric force. And work done by electric force, this is equal to force time t, the distance t. F, this is equal to EQ times t. So this is the force. But if we rearrange this one, we can simply write down this is ED times Q. But ED, this is equal to the potential difference times Q. In this case, the change in kinetic energy, this is equal to Q times delta V. We can simply write down, in this case, the kinetic energy at plate Y, this is equal to Q times delta V. You have to write down in terms of Q and delta V because question is asking you to write answer in terms of Q, V and D. So we can say this is Q times V. So in this case, V is equal to potential difference. Let's try to answer part B now. For part B, it is given to us, state the change, if any, in the kinetic energy of the nucleus on reaching plate Y when the following separate changes are made. It means one change is made at a time. Now, first change is the distance is half, but the potential difference remains the same. Now, if we look at kinetic energy, we have found that kinetic energy is equal to Q times V. It is not depending on the distance between plates. So simply we can say that there will be no change in kinetic energy. So simply now if we go to next one, it is given to us the nucleus is replaced by a different nucleus that is isotope of the original nucleus. So this is very important. Isotope, it means the same charge on the nucleus, same charge, because the same number of protons. So from here we need to understand the charge is the same with a fewer neutrons. Again we need to understand kinetic energy is equal to Q times delta V. For this part, only we change the nucleus. Distance is the same. Potential difference between plates is the same. The charge on the nucleus, that is also the same. So it simply means that again there is no change in kinetic energy when this nucleus will reach the plate Y, because Q is the same, delta V is the same, so there is no change in kinetic energy. For part C, it is given to us that nucleus of carbon-14 decays to form a new nucleus by releasing beta minus particle and only one other particle of negligible mass. This is telling us about neutrino. Now the next thing what we need to understand is that we need to find out, is it beta minus decay or is it beta plus decay? This is beta minus decay because in this case beta minus particle is emitted, so this is beta minus decay. So the first thing we can write down, this is beta minus decay. Now for beta minus decay, we need to write down this nuclear reaction. So in this case, we have carbon-14. This decays to another nucleus. Let's say the new nucleus is X by emitting beta negative particle. So this is negative particle. Now we need to understand this is electron, and electron is a particle, so we can write down here electron, and electron is a particle, so this has to be antineutrino. Electron antineutrino. So atomic number, mass number equal to 0. Now let's try to answer part 1. For part 1, we need to find out the Nucleon number of new nucleus. If we write down here, this is 6, this is -1, so this has to be 7. This is 14, mass number 0, so this is still 14. Very simple one, so I'm just writing directly these answers. So it means the nucleon number is equal to mass numbers. This one has to be 14. And the proton number, this is the proton number. So this one is proton number. We often use letter Z for this, our atomic number. So this has to be 7. The next second part is asking us, state the name of the particle of negligible mass. So this is electron antineutrino. So this is E. So we can write down this is electron antineutrino. So this is electron antineutrino. Now you need to understand, if this is particle, this one has to be antiparticle, means it has to be antineutrino. This is the point you need to remember. So this has to be antiparticle.